Welcome to aimsindia's online classes. In today's video, from mathematics subject, sequences and series topic we are going to continue. In our previous videos, children, we have learnt about sequences and their types, different types of sequences, finite sequence, infinite sequence, Fibonacci sequence, and its formula. About series also we have learnt, and regarding types of series we have discussed. We have mainly three types of series: arithmetic, geometric, harmonic, and we have discussed about them one by one in detail. So now children, let's start today's class with the concept progressions. So if the terms of a sequence follow certain pattern, so then the sequence is called a progression. If all the terms of all the terms of a sequence follow certain pattern, then the sequence is called as a progression. So here 3, 5, 7, 9, 21. We are having a sequence in that some terms are there, but all terms are following one pattern. 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, and so on. They are following a particular pattern. The difference between two terms is constant, so they're having that pattern, so it is called as a progression. That sequence is called as a progression. So previously we learnt about series. Series means summation. It's not only combination of terms, it's a summation of terms. Here whatever we have discussed here, we have discussed about series, which means the summation of sequence. But progression means it's not summation, it's only the sequence. It's only the sequence following some pattern. Next, in second example, we have 8, 5, 2, minus 1, minus 4. 8, 5 means, so we have to, what is the pattern here? 8 became 5, 5 became 2, 2 became minus 1. Means 3 subtracted from the beginning term, so that we are getting the next term. Means there is a difference of minus 3 between any two terms, which is constant. This pattern they are following. So this is also an example of progression, as it is following a definite pattern. Next, 2, 6, 18, 54, and so on up to 1458. 2 plus 4, 6. 6 plus 4, 10. So they are not following addition pattern. Let's see with another operator. 2 3 times 6, 6 3 times 18, 6 3 times 18, 18 3 times 54. Means they are having a common ratio of 3. So that pattern they are following. So this third one is also an example of progression. If we see fourth example, we have 1, 1 by 2, 1 by 4, 1 by 8. The first term also can be written as 1 by 1. So 1 by 1, 1 by 2, 1 by 4, 1 by 8. Which pattern they are following? 1 into 1, 1, 1 into 2, 2, 1 into 1, 1, 2 into 2, 4. Means they are having a common ratio of 1 by 2. Means we accept the first term, all other terms are obtained by multiplying its previous term with 1 by 2. So this 1 by 2 is considered as common ratio. 1 by 2 is considered as common ratio. So this is also having a particular pattern. This is also an example of progression. So progression means it is just a sequence, but which follows a certain pattern. Then it is called as a progression. So we observe that in all the 4 examples, whatever we have seen just now, we observe that each term except the first term is formed by adding 2 to the preceding term in first example, subtracting 3 to the preceding term in second example, multiplying the preceding term by 3 in third example, multiplying the preceding term by 1 by 2, or indirectly dividing the preceding term by 2. Like that also we can tell. Dividing the preceding term by 2, we have got the sequence. That pattern they are following. So each example from 1 to 4 is a progression. But here we have elements up to 21. End element is 21 in first example. In second example, there is no end element. This dots represents this series never ends. It will go on. Third example, again we have end element. Fourth example, we don't have end element. We have dots, which means the series will go on. Means it's an example of finite progression. It's infinite. So 1 and 3 examples are examples of finite progressions. 2 and 4 are examples of infinite progressions. So 1 and 3 finite sequences, 2 and 4 infinite sequences. Next we have arithmetic progression. So arithmetic progression means, so if we see the examples, except the first element, all the remaining elements are obtained by adding a particular constant number to the previous one. 1 plus 3, 4. 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. We are adding plus 3, which is the common difference. Denoted by the symbol D. Here 12, 7. So how we have got 7 means, from the preceding element we have to subtract 5. So 12 minus 5, 7. 7 minus 5, 2. 2 minus 5, minus 3. So here common difference is minus 5. Next, minus 9, minus 7. Minus 7, minus 5. How we have got this minus 7? Subtracting minus 2, adding plus 2. Minus 9 plus 2, minus 7. Minus 7 plus 2, minus 5. Minus 5 plus 2, minus 3. Minus 3 plus 2, minus 1. Minus 1 plus 2, plus 1. 1 plus 2, 3. So here common difference is plus 2. So in each of the sequences, every term except the first term is obtained by adding a fixed number. The fixed number may be positive or negative to the preceding term. Here the first example fixed number is plus 3. Second example fixed number is minus 5. Third example it is plus 2. It may be positive or negative. So in sequence 1, we have added 3. In sequence 2, we have added minus 5 or subtracted 5. In sequence 3, we have added plus 2. Suppose if we have a sequence A1, A2, A3 and so on up to AN, this is called arithmetic progression. If there exists a constant number D such that this sequence can be called as a progression, arithmetic progression, if there exists a constant number D such that T1 equals to A1, first term equal to A1, second term equal to, for the first term, we have to add D, A1 plus D or T1 plus D. Next, third term means for the second term, we have to add D or T2 plus D. Fourth term, A3 plus D, T3 plus D. Tn, nth term, an minus 1 plus d, tn minus 1 plus d, where tn minus 1 is the preceding term of tn. Preceding term of tn. So here this d is called constant number and it is called common difference in the AP. Common difference in the AP. Common difference in the AP. One minute. The constant d is called common difference of the AP. In other words, a sequence A1, A2, A3, An is called an arithmetic progression if the difference of a term and the preceding term is always constant. If the difference is always constant, then it is called as an arithmetic progression. So this constant is called common difference. If A1, A2, A3 up to An, if it is an AP with common difference D, then this common difference D is given by the formula A2 minus A1, A3 minus A2, A4 minus A3, means difference of any two terms, any term and its preceding term. Or in general, we can take like this, An, nth term minus An minus 1, its preceding term. N may be any number. So let's see the example on children. Show that the progression 11, 6, 1, minus 4, minus 9 is an AP. So we have to show that the given sequence is an AP and find the common difference. Common difference also we have to find. So the given progression is 11, 6, 1, minus 4, minus 9. So if we take the difference of any two terms, A2 minus A1, A3 minus A2, or A4 minus A3, we can take any difference, 6 minus 11, 1 minus 6, minus 4 minus 1. Two terms difference is constant, which is equal to minus 5. So each term differs from its preceding term by minus 5. So the given progression is an AP and the common difference is minus 5. Common difference is minus 5. Next. The nth term of a pattern of numbers is 2n square plus 1. The nth term of a pattern of numbers is 2n square plus 1. So, okay, if the nth term they have given, they are asking, is the pattern of numbers so formed in AP? So, with this pattern, if we frame the numbers, that numbers, whether they will be in AP or not, that is the question. The nth term is Tn equal to 2n square plus 1. In the place of n, if we keep 1, then we will get the first term, T1, 2 into 1 square plus 1, which is equal to 3. If we keep 2, T2, 2 into 2 square plus 1 equal to 9. If we keep 3, T3, 2 into 3 square plus 1 equal to 19. If we keep 4, T4, 2 into 4 square plus 1 equal to 33. If we take the difference of T2 minus T1, T3 minus T2, T4 minus T3. Here difference is 6, difference is 10, difference is 14. The difference between each pair of consecutive terms, 6, 10, 14 we are getting, which are different and not the same. So the pattern of numbers so formed is not in AP. Is not in AP. So if they give nth term, if we, by this nth term, if you frame different numbers, it's not compulsory that sequence of numbers to be in AP. So the general term of an AP is, means the nth term, it should not be in this form. The nth term, actually it is called general term. The nth term, it is called general term. it should be in different form so that the numbers formed will be in AP. Actually, we have an AP. Suppose if we have an AP with first term A and common difference D, then this AP is given by A plus D, A plus 2D, A plus 3D. Because first term we will be having only A. First term we will be having only A, which can be written as A plus 0D. Second term we will get by adding D to the first term, which is A plus D, can be written as A plus 1 into D. And third term we will get by adding D to the second term, A plus D will become A plus 2D, can be written as A plus 2 into D. And next term we will get by adding D to the previous term, A plus 2D plus D, A plus 3D, can be written as A plus 3 into D. If you observe all these terms, when we have T1 here, we have 0. This 0 can be written as 1 minus 1. When we have T2, we have 1 here, can be written as 2 minus 1. T3, 3 minus 1. T4, 4 minus 1. In the same way, if we have Tn, we can write here n minus 1. So A plus n minus 1 into D. So this is the general term of the AP or nth term of the AP. So if the nth term is in this model, then the sequence formed will be in AP. So with the help of this nth term, we can find out any term in the AP. But whose first term should be known, common difference should be known. If we know A and D values, then we can find nth term by substituting A first term, by substituting n value, and by substituting common difference. So nth term, general term formula is first term plus n minus 1 into common difference, or Tn equal to A plus n minus 1 into D. If there are n terms in the AP, then An represents the last term, which is sometimes denoted by L. Last term, L equal to A plus n minus 1 into D. Nth term, generally it is represented by Tn or An, sometimes with the small letter L. So how to choose terms of AP means, while doing calculations, we have to choose the terms in AP. If you want to find three terms, instead of taking A plus D, A plus 2D, for calculation purpose, we can remove this A plus 2D. We have A after A plus D on the right hand side. Left hand side we can take A minus D, so that the difference between A minus D and A will be D. A and A plus D will be D. So we can take the terms as A minus D, A plus D. So common difference will be D. Why we are taking like that means, for calculation purpose. If we have 4 terms, if we want to take 4 terms, we can take A minus 3D, A minus D, A plus D, A plus 3D. So that all D's will get cancelled, only A's will remain if we add them. So here common difference is 2D. When we have 5 terms, A minus 2D, A minus D, A plus D, A plus 2D. Common difference is D. When we have to take 6 terms, A minus 5D, A minus 3D, A minus D, A plus D, A plus 3D, A plus 5D. Common difference is 2D. Means when we have to take odd number of terms, we will take terms like that. Common difference is D and A should be in the middle. A should be in the middle. Before that A minus D, after that A plus D. When we have to take even number of terms, we will take terms such that common difference is 2D. There will be no A term. There will be no A term present in the terms. Common difference will be 2D. Like this, we have to choose the terms basing on the number of terms while solving the problems, so that it will be convenient for calculating the values. So for odd number of terms, middle term will be A, common difference is D. For even number of terms, middle term is not A, but A minus D, A plus D. Two terms will come. Because out of 4 terms, these 2 terms are considered as middle terms. In 6 terms, this third and fourth term are considered as middle terms. So common difference will be 2D. Okay, children. Remaining topics we can learn in our next video, children. Thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Please visit our website www.aimstoday.in for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.